Hi, Melanie.
Oh my god. I'm just so frustrated because, like, honestly, if Scobie had missed those two field goals, we definitely would not have won.
Yeah.
Like, it just makes me so mad because I'm just like, well, I mean, like, what are you doing? Like, come on. Like, you can't go over 4, you just can't do it.
Yeah.
Like, don't ever.
Did you actually watch it? Because I didn't actually watch it, I just heard about it.
Yeah, right. I didn't actually watch it. I missed you, and then I was figuring out it. But I always look at the score every couple.
Yeah. I'm like constantly looking at the score and I'm like, why are you failing so much?
Yeah. I'm hopeful. It's like, there's like a minute and 10 seconds left in the fourth quarter, and it was 2017, and I was like, okay,
Just hold on.
Hold on to it. 2 minutes, and then the fourth that happened.
She's really mad. Like the whole season so far, so you're really mad.
Yeah. I'm trying to get an Osberger up, but it didn't help much either, so. Yeah, no.
Losing sucks was a big deal for us, but we haven't figured it out yet. That sucks, so. We're just lucky we have a really bigger.
Yeah.
Yeah. He's my favorite because he can help me with the languages, and I'm like, we're actually working.
Yeah.
That's awesome. You watch Grace?
I don't know.
No.
I had a meeting at 8 o'clock, and I was like, I'm not going to start it halfway through this set. So.
Yeah, I think that like the one theater on my computer, like, we're not in an area where you can do this, and I was like, that's weird.
Did you try to do that on ABC?
Yeah.
Huh. That's weird.
Yeah, I know. Because like my sister's able to do it where she is. I'm like, why can I not do it?
I think ABC really, I was reading online last night. After my meeting, I was going to go home and just watch it on ABC. But it's definitely really fast. So like midnight or the next day after they premiere.
Yeah.
So it should be on ABC. So you can like watch it pretty well.
Yeah, I watched it Friday before work last week.
Yeah.
That's usually when I watch it because I want to get stuff done during work. So maybe I'll just watch it during my hours. Yeah.
Hi, everybody.
Yeah, I watched it.
Oh.
Not allowing others to take Yep. Yeah.
I was going to read it yesterday, and I had time to read it yesterday, and then I just forgot.
We will be on SPSS today. We'll get started in a few minutes, so we'll start just now, but we'll be on SPSS. So if your computer has SPSS running, that's good. If you're on a computer that's having trouble with SPSS, maybe you want to move to a different station before we get into it. Okay, well, I guess my idea to start SPSS kind of killed the conversation that was going on, so sorry about that. But anyway, welcome to Friday. Congratulations on making it through week 5. Is that what that is? Wow. So we're really making our way. Who's ready for a weekend? Yeah, we all could use some REM. I know I can use some REM also. Okay, so a couple of ideas. The great news is that 1 week from today, we'll be turning in exam 2, right? And so we'll have a writing workshop at the back table, as we've typically done. 1 week from today, and I wanted to make sure that people were okay with the assignment. This is the first time I've tried an assignment like this, and I'm really looking forward to it. So I wonder if you can click on this assignment in Blackboard. And I'm calling this looking back and looking ahead. And what it will be is an essay. Okay, we're doing our exams this year all by essay, which I think is an interesting way to synthesize and integrate our ideas. And what we're going to ask you to do is think about what you would like to do in the future, looking ahead, with respect to at least possible academic opportunities. So it might be the case that some people here want to go to med school, some people might want to go to pursue a MBA or a law degree. Many of you might want to pursue some kind of training in a field related to psychology in graduate school. So we're going to ask you to think about what kinds of topics you might want to investigate. And then I'd like each of you to go out to PubMed, or PsycInfo, I guess, could work, but I'm really thinking of PubMed for this one, and see if you can find an abstract, actually 2 abstracts, that are of interest to you. So some of you are probably already applying for graduate school or thinking about that. Others might be delaying for a year or 2. But if you could think about this, what topic in graduate school or medical school, or even at an MBA program, what topic would you like to pursue? And then maybe you can identify some articles on that topic. This might also introduce you to some specific laboratories. It might be the case that you're interested in something for which the University of South Dakota is the #1 school in the nation. Or it might be that you found a particular lab group that's in the state of Oregon, and they're it. And you're thinking that maybe you'd be applying there. Okay, so you can think about where might you be applying, and then how can you use this exercise, how can you use this exam to help set you up for that application process. If you are applying to a lab, it would be helpful to know something about the work that goes on in that lab, right? Something about the actual work. So here, we're going to ask you to apply some of the statistical acumen that you've been developing this semester and in other semesters. And we'll ask you to take a look at, the methods and the intro, certainly, but really to focus on the statistics that are done. And see if you can describe their statistics in the article that you picked. And then also see how you might have taken a different statistical approach to the data analysis that they used. Right? So maybe they used some kind of chi-square as one example, and you're thinking that they could have reconfigured their data and done something like a regression analysis as one possibility. Okay? I think I'll do that for a second article as well. So what was the method like and the intro like for a given article? What were their stats like, and how might you do their stats differently? Okay? I think I'll do that for another article. And I'm not going to ask you to perform the stats. I'm not going to ask you to generate any graphs for this. It's all just writing. I want to develop the writing skills as well. Okay? So that's all spelled out on the assignment itself. That's here. And if I pop that open, we read all the way through, but I wonder if we can get somebody to read, just so we're all on track here. Okay, after you've picked your 2 articles, can we have somebody read these 2 instructions for us? Did everybody find that assignment, by the way? If you click right on the assignment, it comes up in Word. Yep. So I'm going to try to get away from doing a paper handout for you, although I would like you to bring the paper back to our writing workshop so we can circulate the drafts. Do we have a volunteer reader to make sure we're all okay with those instructions? I'd like to read them out loud. Thank you, Sarah.
Also, somewhere in the first 250 words, you can hyperlink to the article PubMed abstract. Next, using approximately 250 words, summarize the studies, statistical techniques, and results. Finally, using approximately 250 words, identify one or more alternative statistic techniques that might provide new information given the data reported in the study. Repeat the instructions in step 1, but now from the second article. Importantly, the statistical techniques in the second article must be distinct from those in the first article. Additionally, the alternative statistic techniques that you suggest for the second article must differ from the one you suggest for the first article. This will require you to think creatively and comprehensively about your statistical knowledge.
Okay, very good. Thanks, Sarah. Okay, so you get the idea. You can pick 2 of these articles. You don't have to attach the articles, but what I would like is as I'm reading your stuff, I'd like to be able to read the abstracts anyway from your articles. Does everybody know how to insert a hyperlink inside of, how many people are not sure they know how to insert a hyperlink? If we're not entirely sure, let's just say, do a real quick one here. If I went out to the internet and I went to PubMed, right, so this is the public Medline database, and I wanted to find an article by Mr. Matthews. Okay, and I found this one. What I would do is I could now grab this URL. You see I'm highlighting the URL way up top, okay? And I'll copy that with a Control-C. And then while I'm inside of my document, let's say that I had made a reference to the Matthews and Clement paper. I would highlight that, and that said Matthews and Clement. I'd right-click. Oops, excuse me. Need to enable this. Okay. I'd highlight that. I would say, Matthews and Clement, blah, blah. Okay, I would highlight that. And then with a right click, you will have the opportunity to hyperlink. And then down here, I can paste in the hyperlink that I want. And then you can check it just by holding down the Control key. And then that should take me right back out to that same article. Okay? That works for us. Who followed that? Okay? So it was a right click and insert that. So just somewhere in your first 250 words, you're describing the article by this person and that person. Highlight that thing, insert the hyperlink. Then in the second half of your paper, you'll start with another article, and you'll do that again. Okay? All right. All right. I look forward to reading those. I hope that helps you. I realize that many people have applications for graduate school that are coming up in Thanksgiving-ish, maybe early December. So we're hoping that this particular exercise sort of guides you, and gets you to thinking about, here are maybe 2 labs I'd like to apply to. One's in Oregon, one's in South Dakota. I'll pick a paper from each of those, and I'll write about those, such that if I'm writing a letter of application, I've now got quite a bit of background on what's going on in that lab. Okay? So hopefully that will set you up. I realize not everybody's applying this year or next year, but probably within the next 5 years, many of you will be pursuing an advanced degree of some flavor. Okay, and this sets you up. So we're looking back at all of our statistical procedures. We're looking ahead to where you might go professionally. Any questions on that? Okay. Wonder if we can do this. That's Friday. That's 1 week from today. Okay, let's talk about the day before that. That's Thursday. That's going to be a computer quiz. And so I have a similarly structured PowerPoint here. This, again, is out on the S drive. I can put it on Blackboard, too. But this is about computer quiz 2. You've seen this slide before. It'll be exactly the same for computer quiz 2 and also for computer quiz 3 and 4. Right? So these are low stakes. Right? They're only 5% of the overall grade, which is 1/32 of your GPA at Denison, which won't matter when you're 25. Okay? The format will be the same as last time. The emphasis here will be computational, hands-on kinds of things in Excel and SPSS. What I've done is the third slide of this is a slide that you had last time around. These were some of the things that you had done for the very first SPSS quiz and Excel quiz. Right? You did that much. These could appear in the upcoming quiz on Thursday, but they're less likely. The reason I put them here is that the nature of a class like this is cumulative. You learn how to do averages in the first week, and you learn how to do standard deviations. Well, you'll have to do something like that, even though it might not be standards and standard deviations and averages. You're doing something very similar when you're manually computing a R statistic, right? So this is just sort of what you had done. Here's the new stuff that's on the slide in the middle. Okay, we did a manual computation of chi-squared independence and goodness of fit using Excel. Okay, we did that manually in Excel. We learned the chi-ind and the chi-dist commands. Who remembers those? Okay. Can somebody just remind us, what do those generally do for us? The chi-ind and chi-dist? Even if you can't remember which one is which, to a first approximation, what do those do for us? Does this help? We had drawn that on the board when we use chi-ind and chi-dist. Yeah, thanks, Karen.
It's the one that tells you either the percentage rank by the standard deviation or vice versa.
The percentage rank? It's like that. It does tell you the percentage of scores to the right of this particular, the cutoff line, the critical region. Right? So it gives us the critical values, the chi-square values we'd have to beat, right, in order to claim statistical significance. It also gives us the sig value, essentially, from SPSS, right, the observed p-value, right? Okay, we also did a whole bunch of manual computing. We computed the R at least 2 different ways manually. We used a z-score formula. We used an R formula. I will hand you all the formulas you need. I'd like you to practice, but you don't have to memorize those formulas. I guess the one formula I would like you to memorize, first, we want you to know how to manually compute standard deviations. You've already done that. How to manually compute a z-score, right? So score minus the raw score minus the mean divided by the standard deviation. Okay. Generating scatter plots, we did that a bunch of times yesterday, linear and nonlinear, and their equations, we developed those yesterday. We were working on how to develop a prediction, and we plugged in some linear and nonlinear variations. Computing predicted values of y, okay, is what that was all about. Okay, so we've done all that in Excel. We've also done correlations in Excel. That was analyze and correlate. Today we're going to spend some time on analyze and regression, and we'll also build some regression equations using what we've got in SPSS. Okay. All right, so those are the main ideas. If we get any further on Wednesday, we might add 1 or 2 things, but that's plenty for you to practice, and there's lots of practice sets out on the S drive. Okay. Any questions about either Friday's exam or Thursday's quiz? Okay. Really good. Really good. Okay, so then what happens on Wednesday? We'll be practicing for Thursday, and on Monday we have our journal club session. And I'll go back to Blackboard one more time. And in Blackboard, you can see that we've got our journal club session notes right over here. Okay, very interesting article on intergroup contact between minorities here at Denison. So Dr. Bickman had looked at students who are Asian and students who are black and looked at intergroup contact there and published a very nice article in 2011 on that. As I mentioned, I hope that Dr. Bickman might join us. She's been invited and she said that she'll try to get here. But she won't be explaining her article. We'll be having our usual journal club session. She'll just be listening in. Okay? And then we'll go to Shelby for the last 15 or 20 minutes of the next session. Okay? All right. So that's what we're doing for the next many sessions. That was busy because we had an upcoming exam and a quiz. Okay, let's do this. Why don't I open up where we left off, and we won't spend a lot more time on this, but just to remind you of something that could be on the quiz, we went through all these different nonlinear regression types. Okay? And you don't have to pop this open now. And we were going through the power function, and also we went through a logarithmic example here, I think is what we had done, and exponential and so forth. The idea is, just as a reminder, we always have these color-coded answer keys. So you can see exactly how the equation is developed either for a power function or for a a logarithmic function. Yesterday, as we were wrapping up, I like to make a couple of errors. Sometimes I make the error where I build the equation properly and it works just fine for the first cell, and then I drag it down and I don't freeze it. And people were correct to point out what was going on there. Yesterday, the error that I had made was I should have put in a ln. This is the natural log, right? I think I put an exp. I was just listening to the video, and somebody in the back row actually said that. Oh, somebody said you want ln, not xp. I didn't hear it, but I heard it on the video. So thank you for whoever that was. So anyway, we want the ln for the logarithmic function. We want the e, or the exp, for the exponential function. That's pretty, I think that's pretty straightforward. Okay? And then we can make our predictions for any given score. Okay? All right, were there any questions on this exercise? The one that we completed from yesterday. Okay, I'll put that away. Okay. And what I'd like to do is go to the handout that you have. Okay. People should have a handout on a simple linear equation. And the idea there is that you've got some indication of how to compute slope and y-intercept. It's one that looks like this. Okay. Maybe that's your new handout. Right? Some idea of how to compute a regression equation based on the quantities that you've already become very familiar with when you go all the way through an Excel computation, and you develop your SSX, your SSYs, and then you get the products. Remember that we talked about the cross products. We come up with a multiplication of this X deviate and that Y deviate. We call that the cross product, and then we get a sum of those cross products, and that gives us SPXY. Who remembers doing that? Okay. If we take that quantity and we divide by SSX, okay, we get the slope for a regression equation. Right? So that's pretty straightforward. And I think I've got an example or two that I can call up. Practice set SPXY. See if I can. Okay. You don't have to open this one, but there are many practice sets available to you, and they all have the same format. Here you would be, filling out all of your regression and correlation components. You'd be developing SSX, SSY, SPXY. You'd have your answer key. This all looks very familiar to you. Right? You've done that kind of thing many, many times. The only twist that we would add, and in the interest of time, I won't make us go all the way through these computations because you've done them a couple of times already. After you get all of that, which you typically are used to doing, we're just going to mix and match some of these values in a way that's consistent with these formulas in order to develop the regression equation. Okay, so our slope, which we have right over here, maybe I can zoom in and make that a little bit bigger. Okay, here's our slope, and all I did for our slope was I went to the SPXY category and I divided it by the SSX. Okay, and you can see that those, the formula there, that's I38 divided by D38. That would give me the slope in my y equals mx plus b equation. Who's following that? Is that working for us? Okay. And then once we have the slope, then it's really easy. We just flip the page over here to get the intercept, and we're going to use that slope one more time. We have to multiply that slope by x bar, the x mean, which you already have. You've already computed that. And we're going to subtract all of that from the mean score from y. Okay, and that gives us our intercept. So just a couple of really simple addition, subtraction, multiplications that go on here. After we've already built up very nicely this SSX, SSY, and SPXY. Okay? So if you wanted to practice all of that, you could. I think that you're probably already quite good at developing all of this. I just thought I'd give you this Excel practice sheet in case you wanted to see how all of that connected with this for the linear equation. This also will be handed to you. So it might be the case that I would ask you to run a manual correlation, and you do all these computations, and I might also ask you to develop the corresponding linear regression manually, and you would use this to do that. Some people think they would be comfortable doing that. Is that okay? Yeah. Okay. So we won't spend a lot of time just doing that simple math, but there's that practice set, and it's called Regression Practice Set SPXY. Okay. One point about this that I'd like to make is that here I'm saying, and you might already know this, but just in case you're not entirely familiar with this, here I have something like high school GPA, and I'm using it to predict college GPA. And a point I've made before, but I haven't made recently, is if I were to take equals Corel inside of SPSS, inside of Excel, and highlight over this guy and highlight over that guy, and hit the go button, I'll get my R value. So far, so good. Okay? If I took those two columns and I rearranged them, and I took high school GPA and I put them over on this side, okay, and I highlighted those two columns, I would get exactly the same R value. Right? The R value doesn't depend on which one is your predictor variable and which one is your criterion variable. You get exactly the same R value either way. Okay? The strength of the correlation between high school GPA and college GPA is the same as the strength of the correlation between college GPA and high school GPA. Who's following that? Okay? So for the R, it doesn't matter. Okay? Here's where it gets just a little bit complicated. If I now go to regression, which is intimately related to correlation, if I use this as my predictor variable and this is my criterion, I'm going to wind up with one particular regression equation of the form y equals mx plus b. If I flip them around, and what used to be on my x-axis is now my y-axis, all of a sudden the regression equation changes. Okay? Right? The regression equation changes, or at least it probably will change for the raw scores. You might get extremely lucky, and by some mathematical fluke, they might turn out to be the same. But generally speaking, once you flip the axes, what was y is now x, what is x is now y, you're going to wind up with a different y equals mx plus b equation. Okay? First, who's just understanding that? Okay, so generally, correlation and regression are going hand in hand. But for a raw score prediction equation, that doesn't hold true. Let me see if I can give you an intuition as to why that's the case. Here, I'm using one kind of GPA to predict another kind of GPA. Okay? So they're both GPAs. So this is a case where it might not be really obvious why when you flip the axes, all of a sudden you get a different coefficient and a different intercept. But let's say I was going to use something like high school GPA to predict your salary at age 40. I know you're not 40 yet, but for those of us who are at 40 camp, this is expressed in GPA, right? And this is expressed over. This would be expressed, our y variable would be expressed in some kind of monetary unit, right? So it would be your salary at age 40. Right? So you can see that if we want to report how we're getting changes in the y-axis, right? In the one case, our units are going to be in salaries. Okay? But if we now flip those axes, we could see what was your salary at age 40. Can we use that to predict your college GPA? Now we've got a GPA unit over here. So the way GPA is measured is a grossly different unit than the way salary is measured. Right? So your y-intercepts would have to be wildly different. One's going to be in tens of thousands of dollars. The other is going to be in GPA points. Who's following that? Yeah, does that make sense? Okay, so they really couldn't be exactly the same equation numerically, even though they're of the form y equals mx plus b. The b in one case is going to be a salary unit. The b in the other case is going to be a GPA unit. Okay. All right. Cool? So if on a quiz you're asked to develop a regression equation, please pay careful attention. There might be an instruction in there that says, and use variable such and so as your predictor, that's on the x-axis, and use variable such and so as your criterion variable. Right? So now we know that we want the y-intercept to be expressed in the criterion variable units. Okay? All right, that's true for raw score regression. Okay? If instead we went to standard units, okay, and we were doing z-scores, then actually that's a lot simpler. Then what turns out to be the case there is that there is no y-intercept. The y-intercept on z-score prediction is always 0. You're using a range of z-scores here to predict a range of z-scores here. Okay? Let's see if I can show you some of these. Okay, so here's a simple demo that says regression sequence matters. Okay? And you don't have to call this up, but here I'm doing annual income as a function of IQ. Okay? That's the R squared, and that's the best fitting linear equation for that. Then I flip the axes. I'll shrink that down just a tad. Okay. I flip the axes over here. Now I've got annual income and IQ, very different units. I wind up with exactly the same R squared, because I would have the same R in the two cases, 0.9394, but you can see I wind up with very different values for my y equals mx plus b equation. Okay? That's the first point. Now let's see if I can show you how we get a difference. Does this one work? Okay. Okay. Here, I've got now a set of raw scores. Here's raw SAT. It's predicting raw GRE. Some people here are about to take a GRE or an MCAT, or maybe you've taken one recently. Right? Oh, did I hit close to home? Is that like this weekend or something?
We're taking the subject test.
Like this weekend? Oh.
24.
Okay, sorry to scare people, right? Actually, I picked this. I know that this group is always, about to do that. So here's some raw scores, right? Okay, and then what I've done over here is I've simply z-transformed them, right? We all know how to transform. So these scores are related to these scores. Those are the raw ones. Those are the z-scores. Okay, and what I can do is create a simple scatter plot over here that has the best fitting raw score value. Okay? And then same ball game down here, these blue guys pertain to these blue guys. Okay? So the slope should be very similar. The R squared should be exactly the same as I hit my F9 key. But you might notice that what happens in the blue case for z-scores is the y-intercept is always right here at 0. Half of these z-scores in any population are going to be negative and half are going to be positive. Who remembers that about z-scores? Right? You have that bell-shaped distribution. Here are the negative z-scores, here are the positive z-scores. Okay? So the middle of that is all going to be at 0. Okay? So it turns out that our intercept for any kind of z-score regression is going to be at 0. And then the slope that we have is always going to be equal to the R value, interestingly enough. So it's a very beautiful property. I find it to be a very elegant property of z-score correlation, is that if you do a simple z-score correlation and then a z-score regression, I should say, you've got your R value as the slope of this line. Okay? So your regression equation, if you plotted things as z-scores, is always that y is equal to mx plus b. B is always 0, so all you really have is mx, and that m turns out to be the correlation coefficient, okay? Which is pretty cool. If you're just taking a simple correlation, that tells you the slope of the best fitting straight line if you're plotting your scores as being z-transformed on this axis and z-transformed on that axis. Who's following that? Okay? I just think that's gorgeous. I think it's just so elegant. And once you've done the simple correlation, you've got an immediate intuition about how steep the best fitting line is on z axes, zx, zy. Okay? And I won't ask you to go through all these computations here, but you can open that up anytime you like. Inside of your practice sets, hold this down and just see how all that's related. Okay? Any questions on all of that? So just to summarize some of that, we're talking about correlation and regression. And generally speaking, if we're using raw scores, it doesn't matter what's on what axis for correlation. For regression, it matters very much what's on what axis. If you z-transform everything, that problem goes away, okay? Because everything is in standardized units, and we know exactly what your y-intercept is going to be. It's going to be a 0. Okay? All right. We've had enough of Excel. We've been a little heavily weighted toward Excel. Why don't we go to SPSS? So if you can begin to open that up, maybe you've already done that. Okay. And as that's coming up, I want to set the stage for how we can proceed inside of SPSS by using their regression facility. Okay? Now, in order to get the conversation going here, I would like to just remind us about how we establish variables in SPSS and maybe transport information from Excel into SPSS. Okay? So it would help, I guess, if you do open Excel. We won't do any computations there, but we'll use Excel to generate some random numbers. Okay? So can you open Excel? And maybe you can generate, I don't know, something like 16 random numbers. You can use equals rand. And we'll generate a column of 16 of those. We'll call that factor A. Okay, right? Factor A. Inside of Excel. Okay. And then right next to it, we'll have factor B. And we'll generate 16 other random. It doesn't matter to me what range you use. You use any numbers that you like. And we'll get maybe 16 of them. Okay? You can hit the F9 key a bunch of times to get your random numbers going. And then when you're set, maybe you can highlight your 2 columns of numbers, your 2 vectors. We'll do a Control-C. And we'll have something to paste into SPSS. That's really where we want to be. And inside of SPSS, I've created two variables simply called factor A and factor B. And you can use your control V as in victory to paste in your random numbers. So all we've done so far is create two variables that have maybe 16 observations in each of them, and we have the desire to correlate and regress these two. Okay. Show of hands, how many people have got that? Did I lose anybody there on building the variables? We've done something like that before. So far, so good. Okay, just as a reminder, if I wanted to run a correlation, what would my clicks be? What would I be clicking on? Yellow them out? Analyze. And I'm looking for, let's say I just want to get the R statistic. Okay, we would do correlate, right? Okay. And we would take bivariate, right? That's what we've got there. What we could do, this is something we hadn't talked about before, we could click on Spearman in addition to Pearson. Anybody remember what Spearman does for us? We didn't talk about it in this class, but you might remember from the intro, or from Psych 200, excuse me. I might remember Psych 200. I think people did both Pearson and Spearman in Psych 200. Yeah, some people did. Does anybody remember how they differ from each other? The both all... relationships. So they're very similar in that way. Anybody remember? You can say, yeah, thanks.
I'm not really sure, but I thought Spearman was typically used for like ordinal data.
That's perfect. That's exactly what that is. Okay. So what normally happens is that if we have scale data, that's data that are existing on either an interval scale or a ratio scale, and those two scales are called, sadly, scale inside of SPSS. Right? Okay. So if you're on a scale, okay, you would use the Pearson. If you're on an ordinal, you would use the Spearman. Okay, that would be the idea. But they operate in largely a similar interpretive way. Okay. So anyway, we click on that, and we would get our output, and away we go. If you want, you can take a look at that and see what your correlations are like. Okay, yours will be different from your neighbors. Yours will be different from mine. You get an indication of whether we're significant or not here, factor A, factor B. And we get this value, which is the correlation coefficient, okay, R. Okay? All right, let's see if we can now build a regression equation for the data that you just plopped in. Anybody want to take a guess at how we'll get that one going? What's a good first move in SPSS? Analyze, all right, and then we start looking up and down. Regression, okay? And we can do a lot of them, right? Look, why don't we take linear? And if you wanted to make notes of this, that's fine. By the way, I've also placed, this morning I thought I'd just put it out on the S drive. I've got this here, so here's regression in SPSS. You click on Analyze, Regression Linear, and slide your predictor variable into the IV box and your criterion variable into the DV box, okay? Remember, again, you're going to develop a regression equation, and probably because you're using raw scores, if you had flipped your DV and your IV, you'd wind up with a different equation, right? Because IQ is not measured in the same unit as salary, okay? All right, so we'll do that much, and we'll go Analyze, Regression, Linear, okay? I'm going to slide in factor B as my dependent variable, factor A as my predictor. It doesn't really matter to me how you go about doing that, okay? And even with that much, we can click on OK. And we get a bunch of regression output that you see here. How many people get that? Are able to generate regression output? And I'm not sure everybody's there. Let's just see if we all got regression output. Okay, I think that's everybody. Okay, some of these boxes that come out are more informative than other boxes. What I do like is that here they're giving us an ANOVA that we don't have to look at for the moment, but what I like about this is it's a reminder to me that one of the themes that we will develop as we go into the next couple of weeks is that there's a formal mathematical similarity between t-tests, ANOVAs, and R statistics. And we'll come back to that when we look at how ANOVA is relatable to regression in just a little while. Okay? Here's a model summary, okay, that we've got for this particular regression. So they're giving you the R value, and they're that. And we can get into why they might be adjusting it or what the standard error of the estimate is at some later point. But if you wanted to know what your R value is, you get that right there. So on some level, using regression might be more efficient a set of clicks than using correlate, because the regression click will also get you an R value in the R squared, which is what you wanted in correlate. So you have that. Okay? All right, what we want to do is come down to the coefficients box to develop our equation. And remember that in y equals mx plus b, we have some scaling factor, that's our m, and we also have some constant. So our constant is going to be right here, and these are unstandardized. You can think of that as the raw score value. Okay? And our slope is going to be associated with whatever our predictor variable was. Okay? It's going to be over here. So my equation would be y equals minus 0.324x plus that b value. Okay, you all have slightly different values than I have. Who's okay with that? Can anybody tell me what this equation would have looked like had it been the case that we wanted to use not a raw score formula, but instead a z-score formula? So instead of saying y equals mx plus b, where y is a raw score, x is a raw score, can we play the same ball game, but now we want to have those be z-scores? So we're trying to predict zy, if you will, the z-score for y, given that we have on our x-axis the z-score for x. What would that equation look like? Anybody have an idea? Based on our friend, the coefficients box. Some people are not sure. Okay, all right, really good. Turns out that our friend up here, the R statistic I mentioned a moment ago, the R statistic actually is the slope of the best fitting z-score equation. Okay, so you see 0.29 up there. You might also notice over here it's 0.29. Actually, and they've captured the negative. So this is the better way to go. Okay, so that's the slope of our z-score equation. Okay? So, and what is its intercept? 0, okay? So there's nothing here, and there never will be anything there, okay? Because in the standardized coefficient, and that's what they mean by, you might remember that we called the z-score the standardized score, okay? How would you have to scale up or scale down your standardized x score? Well, you have to do it by that much. And what would the y be? Well, the y is definitionally 0, okay? So there's nothing there. So it would be zy is equal to, in my case, minus 0.29 times zx. Okay? Jot that down if that's not entirely clear to folks. My predicted score, okay, for zy is equal to, and here's my coefficient, minus 0.29 times zx, and if it makes you feel better, plus 0. Okay, so you can see that it's y equals mx plus b. Okay, and this one is actually the R statistic. Yeah? Right? People okay with that? Okay. So out on the S drive, if it helps you, I do have this little cheat sheet that says, here's regression in SPSS. This is what you would click on. Here's what the output would look like. And then here are some of the different boxes. And here's where you're going to pick up your raw score y-intercept, your raw score slope. And then over here, your z-score slope, that's also the R statistic. There is no z-score y-intercept. Okay? All right. Questions on any of that? Okay. All right, so I think we are now regression experts. We've done a whole bunch of linear regression. We've done linear regression in I don't know how many different ways, z-scores, raw scores, Excel, SPSS. I think we've got the regression thing down. Okay? All right. I wonder if we can have at least a brief conversation about what you were doing for today's TED Ed. So with all of that regression in our back pocket, we went on to talk about such things as effect size. Okay? And we went on to talk about such things as power analysis. And a whole bunch of TED Ed questions. And we won't have time to go through all of them, but I thought I'd just see if we can have some conversation about some of the main ideas there. Can somebody in their own words explain what we mean by the phrase effect size? And also maybe how it differs from statistical significance. We spent a fair amount of time on statistical significance so far, but we haven't talked about effect size. here we can see whether something is significant or not, but we also want to know about effect size. So what is that, and how is it different from statistical significance? Okay, thanks.
The effect size is a way to measure the influence that the independent variable has on the dependent variable.
Okay, great.
And it differs from statistical significance because that's just saying whether a result that you found was due to chance.
Okay, right, yeah, it's an important point. So what is the likelihood that a particular outcome was due to chance? That's really the issue in hypothesis testing, right? And that's what our sig value, our p-value is telling us, okay? Now, it could be that we have a case where something is unlikely to have occurred by chance, but there still isn't a real strong effect of the independent variable on the dependent variable. It could be that that's a fairly weak relationship, but it could be a reliable relationship. Right? It can be a strong, it can be strong or weak. But all we're saying when we're talking about this is really we're speaking to the issue of its reliability. Okay, that it's unlikely that happened by chance. If you ran it again, the thinking is you'd probably get something similar. Okay? If we wind up with a low p-value. Okay. In your own words, can somebody briefly explain what Cohen's d is conceptually, and then maybe we can define it computationally? And it's fine if you want to look at your responses online. So we're up to Cohen's d. You may have an idea about what this is conceptually, or if you prefer to start out computationally, that's fine too. Okay, thanks, Mom.
Well, it is a measure of effect size, and what I got is that it like standardizes the data. It's like the standard measure, like a z-score is the standard for
Excellent.
raw data.
Right, okay.
And it's measured by subtracting the mean for population 2 from the mean of population 1, and then dividing that quantity by the standard deviation.
Excellent. Okay, really good. And we're going to assume anyway that we have some known quantity for the standard deviation of those two, right? And it's very much like a z-score, right? But now what we're doing is instead of taking a raw score and finding its difference from the mean, we're taking two means. For example, we might take something like the mean of your scores on a GRE before you take a Kaplan preparatory class, and then after, okay? And we see to what extent we have some effect there. Is this Kaplan thing working, or is this Kaplan thing not working? And to what extent, to get back to Hannah's point, to what extent do we have an influence of our manipulation? Okay, so why don't we look at the mean scores before, the mean scores after, okay, which is typically what we do even in a t-test, but then we'll standardize that. And when we standardize it, we get some dimensionless unit, right? It's no longer expressed in SAT scores or GRE scores. It's just some fraction of a standard deviation that we're moving across. Okay? And higher scores there show larger effect sizes. Okay. Okay. I have a couple more questions that I'd like to do on this, but we can pick up on those on Wednesday. There's something else I really wanted to do. This is October 2nd, and we've now had something like, nearly 5 full weeks of TED-Ed lessons, and you are my pilot group. TED-Ed only recently came out to the world, and Draw 2 is even newer than that, I think. So we've been doing Draw 2s, we've been doing TED-Eds. I really would like to get some feedback from each of you on how that's working. So I'm going to hand you a simple sheet, and I'd like you to take maybe 10 minutes or 5 minutes to fill this in. Please don't put your name on this. Please don't put your Slater box on this. I'm not interested at all in who's saying what. I'm trying to get some feedback on how can we use TED-Ed effectively. And if something is working with TED-Ed, I'd like to know that too. So the first question that is on this list is, what I like about how we're using TED-Ed in this class is that, so this is what's working. You can fill that in. Our use of TED-Ed in this class could be improved if, blah, you can fill in the blank. And then finally, what else would you like to tell me about our use of TED-Ed in this class? I have a handful of people in this class that are also using TED-Ed in my sensational perception class. Can you try to focus your response here to this class? I'm going to give the other class an opportunity to do this, I think, probably not today, but maybe on Monday. Okay? All right, so I'm going to give you one of these, if you can pass down. Please, no names, no Slater boxes. We'll just take the remainder of the period to, there's another one, the remainder of the period to fill these out. When you're done, could you please put them face down on the back table, short one, face down on the back table, and you're good to go. Right? You're good to go. We'll look forward to Monday's session on Dr. Nida's article, really interesting, and we'll hear from Shelby. also, can you try not to focus on any one TED Ed question or any one lesson. This is sort of over your 5-week experience. Okay? Thinking broadly about your 5-week experience. I'm sure I've got a couple of questions that are clunkers.